Hello, Mariette.
Hi,
How are you?
I'm good. How are you?
Not too bad, not too bad. Got our fun little last lecture here. And Siobhan, hello. Welcome. Okay, so how are you guys doing? You guys have any questions about the lab that I can answer before we get started? We have a few minutes to get started. Anything that on your mind? Did you look at all the cool stuff that you have? You have a whole bunch of stuff to do, right? Not that much. It's actually just a little bit. In fact, I did your homework today just to see how it goes, and it went perfectly. So I'm pretty sure you guys can do it too. So there's two different things. One is going to take you like 5 minutes. It's really quick. And then the other will take you a couple of hours, but you just have to go outside for a few minutes at a time and measure the altitude of the sun. Did you see that already?
No.
No, okay, I'll tell you about it. So anyway, did you have a story you want to share today?
I finished a 15-page research paper over the weekend.
Congratulations. That's
Thank
awesome.
you.
That must feel great.
Yes, I have time now. I got to go to the beach earlier. It was nice.
Woo!
So,
Great. Was it nice and hot?
it was actually rather cool. I wish that I was in a long sleeve shirt instead of a tank top, but I kind
Really?
of got a little bit cold too, so it's okay.
Yeah, I was there on Saturday, but went down to Summerland Beach. It's actually a pretty nice little beach. Yeah, it's fun. Feels good. Feels like it's going to be a nice summer. Hopefully we'll get out of the quarantine and we won't have to be so isolated.
That would be nice. That'd be very
That would be very nice. Where do you live? Do you live here?
Santa Barbara.
Okay. You staying in Santa Barbara?
Yeah.
Okay. Are you from here?
Yep.
Oh, you
Born
are.
and
Okay.
raised. So,
Born and raised. Where'd you go to high school?
Santa Barbara.
Oh, Dawn. Hey. Once a Dawn, always a Dawn. Okay.
Yes, indeed.
I feel so bad for the students this year, though. They're not going to
They
get
don't get to graduate.
Well, they get to graduate, but
Oh.
not in the new stadium. You know, the brand new stadium that they finally.
I mean, I didn't get to graduate in the stadium either. I got to
Oh,
graduate.
where
at
did
the
you
bowl.
graduate? Where was it?
At the bowl. I mean, I graduated last year, so
The bowl is awesome.
it was fun.
That's
It was
neat,
fun.
actually. Have you been to a concert there?
Yeah, two. Michael Fronty and Spearhead and Blondie.
Oh my gosh! Wow, cool. You just graduated last year, huh?
Mm-hmm.
Mariette, are you from around here?
Yeah, I was born in Santa Barbara, and I also went to Santa Barbara High. My parents
You
lived there.
did. Oh my gosh, we're all Dons.
Woo!
Class of '85 here. Long time ago. Did you guys? Oh, so well, you don't have to say anything, but anyways, the reunions are pretty fun. Actually, if it's you just graduated, then you don't have to worry about that for a while. But I was kind of surprised, people that I didn't really know that well. You just kind of vaguely know them, and then you come back years later, and you might have even not liked them that much, but everybody kind of mellows out over time, and it's actually very, very fun. I enjoy it actually. So they have these. Did you graduate recently, Mariette?
No, a while ago. I'm a returning student, so
You are? Okay. Well,
I also tested out early, and I've never gotten an invitation to go to a reunion.
You didn't? Well, I am personally inviting you. And actually, you don't have to do this, but there is a Facebook group. And then they've actually been having these, instead of like every year, they've been having like multiple year kind of parties, which is a little bit more fun even, because then you don't have to worry about just one class or anything. But the people are really friendly. And yeah, I mean, it's been a couple years since I've been, but I think they're pretty fun. So you graduated early, huh?
Yeah, a year early.
You were kind of advanced or something? Or you just wanted to get tired of high school?
Right.
Right. Time to get out of here. Get out of Dodge. Okay, well, you guys are here and it's 4 o'clock. So did you want to tell a story?
Yeah, I have some stuff about Virgo.
Okay, well, but is it the story? You're going to tell a story? Well, maybe we'll wait a few minutes and I'll just get started. And then after we see if a few more people show up, then you could tell your story. Otherwise, you could tell your story for the people on YouTube. There might be people on YouTube. Oh, there's Dree Lynn. Okay, we have nobody watching on YouTube at the moment. So anyways, it's fine. Actually, but you get extra credit if you tell your story. So Siobhan, same for you, but this is your opportunity, so you better tell the story real quick. Actually, this one year, somebody's like, I want to tell a story. I'm like, did you actually go research the story? No, but I could make one up right now. And the guy's like making up a story. It was really bad. I was actually kind of embarrassed. So anyways, don't do that. But if you have a story to tell, that would be great. But maybe we'll wait just a couple minutes and get started. And then after we have a few more people, there's Julia. Hello, Julia. And so we have a chat. You can say hello in the chat. Hi, everyone.
Hey.
Hi, everyone. Hello. And Julia, you want to tell a story today?
Hello. Can I read my story?
Yeah, you can read it. Yeah, I mean, you could read it, but it's better if you can at least, yeah, you can read it. You can read it, but maybe try to read it in a storytelling kind of way. How about that? Can you do that?
Right.
Okay. Okay, good. Okay, so you guys, I'm gonna get started. It's 4 o'clock and we have a lot to do, but this is our last class. So we don't meet next week. This is it. And I feel very sad that you got cheated out of some extra observation times, but or not extra, but you got cheated a little bit out of your telescope time, but this is what we're doing. So we'll do our best. But if we get over the quarantine and you just have a desire to look through a telescope, please remember that I will give you a special opportunity. All you have to do is send me an email. And if I can have you join one of my classes, great. Or if you just want to come out and use a telescope one day, we have star parties. Although I don't know what's going to happen this year, actually. This year is unfortunately a big mess. So the AU, who I work with every month to do the star party, they've said we're not going to have any more star parties this year. So I don't know. I'm not sure. It would have to be kind of safe, in order to happen. But I'm gonna hopefully be able to do something in the future. I get to go out and use the telescope anytime I want, but I would love to share that with you guys as well. In fact, we'll talk about things that you can do even if you don't have a telescope, things to try to do in the near future if you can. Okay, so actually we'll talk a little bit about what's in the sky right now. In fact, there's some really cool stuff happening that you guys can take a look at. In fact, one of my students last week said they saw a fireball in the sky. Do you guys know what a fireball is? It's a shooting star, which is actually a little fragment of material from space that really is glowing and burning with its own light, not just lighting up the atmosphere, but he could see this very slow glow. Somebody on Friday was telling us. And it happens to be that this is the Lyrid meteor shower time right around now. So it's very likely that he saw one. I mean, they happen every day. And if you get to see one, it's really awesome. It's so cool. So if you just happen to be outside looking at the sky, you may find that you see something like that. If not, we have some guaranteed really neat things to look at. One of them in the evening and the other if you get up early in the morning. Anybody get up before dawn sometimes? Anybody raise your hand? Yeah, I do. Once in a while, maybe. Walk your dog? No. Anything? Cat? Okay. All right. Well, I might encourage you to try, but you don't have to, of course. It's just encouragement. But let's take a look at our website. Hold on. Let me put it up. And let me tell you about all the things you need to be doing. It's not that much, just a little bit. But there are things that you need to get done before the end of class. And then when you do all that, you are kind of done. And I will get your grades in by next week. Actually, I may even be able to do it sooner, but probably not much earlier than next week. Okay, so we have a few things. First of all, today where's today? Is April 27th. Okay, so if you look in here, you can see some of the topics we're going to cover today. Messier objects. I have a link here to the Worldwide Telescope, Google Sky. These are kind of fun little things. M1, the Crab Nebula. And then, okay. And then there's some questions. There's actually 10 questions, and they're really easy if you follow along with the lecture today. They're not meant to be really hard, but you do get 2 tries. So if you mess up, please try it again. And if you didn't watch very carefully, maybe go back and watch that section again before you take it a second time. Okay, and I actually downloaded a new application because I was really dissatisfied that none of these really shows a good radio astronomy survey. But anyways, I'll show you that. You guys are going to get a little better than last week. So let's see. This is due. This is due already. Way due. Overdue. These are overdue. Why am I getting the notice? I don't know. Okay, extra credit. If you want the extra credit, it's due by tonight at midnight. If you want to do, like I said, if you want to tell the story, then you hop on right now and with us, and you can tell your story live on Zoom. And then here are some other things. Okay, so let me talk about the homework first, which is kind of like homework. There's 2 activities here. One of them is 5 minutes. This is a 5-minute activity right here. I mean, it could be maybe 15, but it's certainly not very much time. And this one technically takes 2 hours, but really I did it today, and actually I just set the alarm for the times that I wanted to do the observation. Each observation takes like a minute, 1 minute, and then you just have to wait. And there's it's about 2 hours in total, but it's really just 5 minutes of your time. And you're going to be measuring the altitude of the sun. Let me look at this one first. Okay, so I just did this, and I promise you it's very doable. But this is your astrolabe. So if your astrolabe is broken, you need to fix it so that you can use it. And you can see that the arrow on the top and the arrow on the bottom both have shadows, and that is definitely from the sun. And you'll notice also that the string is hanging into this section marked altitude. Now, somebody from last week had trouble, and they've turned in the answers. You're supposed to turn in some answers, and I'll show you where you do that in a second. The numbers you're going to read are the inner numbers, not the outer numbers, right? They're the inner numbers here. Okay, so please make sure you double check that. And so what you're going to do is use your astrolabe to determine when it is local noon. Local noon is the time when the sun is crossing the local meridian, and it is at the highest altitude of the day. Hold your astrolabe vertically so that you can see the shadows of the arrows, and have the string hang vertically in the section marked altitude. Rotate the astrolabe, changing the azimuth so that the shadows get longer but can still be seen. Rotate the astrolabe, changing altitude, right, with your arrows, so that the shadow from the top arrow lines up with the bottom arrow or the dark line right here. Okay. Tilt the astrolabe over so that it catches the string. You can watch this video to see an example of a measurement being done. Okay, so you can click on this link, and it's me, and I'm talking, and I did it right out here. So. All right, I'm going to show you how to use your astrolabe to measure the altitude of the sun. You'll notice that my astrolabe string is hanging in the altitude section, and I want to be able to turn it so that I can see the shadows. So make sure that you can see the shadows. They're going to get longer as you get closer to the sun. You want us to be kind of close to the sun, and then you're going to go ahead and tilt it up so that the arrow shadow is actually lining up with the other line, and then you just tilt it over and you can get the angle. Okay, did everybody see that? Everybody see how that worked? Okay, so hello, I don't know how to change that. Okay, let me go back. Okay, so record the altitude of the sun for a 2-hour period starting at 11:30 and going until 1:30 p.m. If you would like to see the local noon time more precisely, you can record the data more frequently, but you're not required to. The suggested times are 11:30, 12, 12:30, 1, 1:30, okay? And then you're gonna enter your data. I'm gonna show you how to do that right here. So you take the quiz when you're ready to enter the data, okay? And so here is your data, right? Record your data in the box below. Your data should look something like this. My numbers are made up. Okay, don't put in my numbers, otherwise I know you didn't actually do it. And it turns out really cool. You can use this table and make a table. And you can put in its 5 data points. If you want to put a heading, you can put 6 rows if you want, okay? And so, I mean, if you want to be super pro, here's my super pro method for entering the data. Put it align center, and then let's put the time. and then the altitude of the sun. Okay, this is the pro way. Okay, and I've got 11:30 here a.m. and then 12 noon. Okay, 12:30. I mean, I don't know, just type it. Okay, 12:30. Oops, 30 and 1 and 1:30. Okay, so 1:30, and then you're going to put in your numbers. So I'm going to just put in the numbers I had, and you only need to get to the nearest degree unless you want to try to be more precise, but you don't need to be. Close enough, good enough. Okay, and then the last question is based on your data, right? Based on my data, what time is noon? Well, I don't know. I guess this one, right? I guess 1:30 is what I would put. I'd collect the answer and I submit the quiz. Okay. You only get one try. And by the way, this is 10 points. Now, if you don't get it right, don't worry. I'm not going to actually mark it worth, you're not going to get 0 points, but I do want you to know that you got it wrong. Okay. So if you get it wrong, just know that something went wrong. But I don't expect you to be a professional. So I will look at all of your work. And if your work is legit, you get full credit. Okay. So please don't worry. If you happen to get it wrong, it's just, I just want you to be aware and I don't want you to change your answer. I want you to give me the an honest answer. Okay.
So
All right,
just
so that's
highest
the
degree
homework.
would be the noon.
Sorry, one more time.
So just the highest altitude would be the right.
Yeah, whatever time you got the highest altitude, go ahead and pick
Okay.
that one.
Okay.
Okay. Yeah, yeah, it's really kind of straightforward. And actually, when you get the answer, you'll be like, oh, well, that's obvious, right? That should be the answer. But anyway, or maybe not. I don't know. Maybe not. Okay. And then the second activity is you have to track Mars for 9 months. Okay. So I want you to come back in 9 months and tell me what happened. Right. I'm just kidding. Wouldn't that be
No.
cool? You guys could just take my class for a year. Just kidding. Okay. I know you're like, oh, Sean will go over this. Okay. Actually, let me just edit and so you guys are not confused. Your start date is June 1st, 2020, and the end date is March 1st, and today is the 27th, okay? Okay, and you are going to upload a picture in just a minute, but I want to show you exactly what to do. Okay, so actually before we go on, let me show you how to do that assignment. It's really a 5-minute assignment, maybe 15 if you want to do a really careful job. But you're going to need to find page 22. Somebody find page 22? Page 22. Okay. And this is going to be, yeah, I know you have stuff on it already, but right now we're going to track Mars. So we're going to use this page to track Mars for 9 months from June 1st of this year until March 1st of the next year. Okay. So I'll put that down and in a minute I will show you exactly what to do. Okay. Actually, one thing you could do is if you already have something on there, pick a different color pen or pencil and use that to make the track for Mars. Okay. So let me get my stellarium up. You're going to need stellarium. And you can use stellarium web if you have to. That's fine. It's not a problem. And then I do want to show you what I'm doing so that you guys, some people are confused on how to use this. So that's partly what I'm doing right now is teaching you how to use it, okay? So I'm going to share my stellarium with you. Take a look. Okay, so everybody sees stellarium?
Mm-hmm.
Okay, and first thing I want to do is turn off the sky. Okay, turn off the sky. And I'm going to turn off the atmosphere, basically. Sorry, that's what I meant, the atmosphere. You could turn off the ground as well. Why don't we just turn off the ground, actually? Okay. And then what else? What's this? Cardinal points, we'll leave that. You could turn off the meteor showers. There's a little tiny meteor shower in this region. You can turn off satellites if that's distracting. Turn that off. Okay. So I've turned a bunch of things off. The next thing is to find Mars. Okay. So let's find Mars. Okay. So you just type Mars and you go whoop, and it finds Mars for you. Great, isn't that easy? Okay, now I forgot I do want to do something. When you do that search like I just did, it automatically centers Mars and you can see there's a little, this thing is lit up saying that it's centered on the object. If you press that again, it's not centered on Mars, and Mars will move. And if I just click that, or if I press the space bar, okay. And now I'm just going to pause the clock and keep it from moving. Okay, now I do want to see the constellations. So I want to make sure I put on the lines for the constellations and maybe the names as well. Okay. All right, so this is today's date, and I told you that the first date is supposed to be June 1st. So how do you change the date? By the way, the right click gets rid of the information, okay? And left click to get the information, right click to get rid of it. If you go over here, you're gonna go to the little clock, and it says date and time, or you can press the F5 key if you wanna do that. Okay, and I'm going to go ahead and advance to, actually I can just go forward now to the first, okay? So let's take a look, and actually, can you tell me, oh, there's a really cool thing. I think I showed you guys this. I forgot something. I do want to look at, I want to look at just Mars, but I do want to show you one more little thing. I think I showed you this already. If you go to Sky and Viewing Options, and you want to look at the constellation boundaries, you click on Star Lore here, and then Show Boundaries. Okay, and so I'm going to ask you a question right now. What constellation is Mars in right now?
Aquarius.
Aquarius, clearly in Aquarius. Okay. Now, do you recognize any of the constellations nearby? I don't think we ever did Aquarius, by the way. I don't think we did, right? But do you recognize any of the other constellations?
Yeah, I see. Go ahead.
Pisces, Pegasus.
Pegasus, Pisces, right? You recognize Andromeda, right? That's cool. So actually, everybody look at page 22A with me. And can you see where Mars would be? And I'm going to go ahead and I'm going to use some of the clues right here. If I look at this edge of Pegasus, it's almost, if you keep going, this is about the same distance, right? Right around here. And it looks like if I went 2 of them, I would be too far. Like almost this distance right here, 1.5 or something like that. It's just a little bit over from that. Does everybody see what I just did? And I just want to try to figure out where should I put that first dot on my sheet so that I can place Mars correctly. So I know it's in the constellation of Aquarius, but it's not far from this, which is one of the fishes of Pisces, right? This is one of the fishes of Pisces. And it's definitely also, if I use Pegasus, it can help me. So if you just take a moment, let's go ahead and do it together, and we can all put this on our sheet together. Let's find where to put Mars, okay? So if I tilted the sheet sideways, you can see more like what we had in the stellarium, right? This distance right here, I'm gonna go ahead and go 1, I'm just kind of giving like a quick sketch, 1, and not 2, but like a half, right? And then just a little bit over, right about here is maybe where I'm gonna put Mars. I'm gonna put 6.1 Mars, right? Mars, okay. Does everybody put that? You got a place to put Mars on 6.1, June 1st. Okay, so I have a starting position. Everybody
That's
good?
actually almost really close where I already had Venus on
That's okay. Maybe you could use a
January
different.
27th.
That's very funny. I know. So use a different color pen, maybe.
Okay.
If you have a different color pen, like I could have done actually. In fact, I did it with I did it in red here. Okay.
Mm-hmm.
Okay, so you want to use some color that you don't have so you can track Mars. Okay, so now I'm not going to do the whole exercise with you. Well, yeah, I am. I'm going to do the whole exercise. Never mind. I'll just do the whole thing, but I'm not going to do it very slowly. So you're going to have to go back and do it slowly. Okay, so I want to go through the entire 9 months. So what I'm going to do is I'm just going to hold down my cursor. I'm going to press the day, and then I'm going to hold it down. And you can see Mars is moving. Oh, oops, I forgot to center it again. Let's center it, sorry, okay. So, and now Mars is moving, and you see it's moving towards the east, so we call that prograde motion. And then if you watch carefully at some point, it kind of slows down, and then, whoop, wait, look at that, it's going backwards. What's that called?
Retrograde.
Retrograde motion. I want you to catch that whole thing and then whoop, it seems to be going forward again. Okay, everybody good? It's pretty easy, right? This is so easy. I just want you to track it. You don't have to put every day, but maybe every week or so. Oh, can you guys, sorry. Okay, so you wanna, we're gonna keep going. We're gonna go all the way until March 1st. And I picked March 1st for kind of a reason. If you take a look right here, what is Mars right next to on March 1st? Who recognizes that?
Ladies.
That is the Pleiades star cluster. So it's just a little bit below it. And you know, now we're just using our judgment. So
Is
we're
that
just
March
trying-
2nd or March 1st?
I meant to put March 1st, sorry, March 1st,
That's okay.
just a little bit behind there, okay?
Yeah.
So you're gonna go ahead and try to put in a second dot. So take a look right here. I'm gonna go to the Pleiades, right? And it was just a little bit below, right? Maybe just a little bit behind. And that's gonna be 3/1/2021, okay? So I have a dot for Mars on the final date. Now your job is to finish it, right? So I've got the starting date here, 6/1, and the final date here. And then it did something in between, right? It went retrograde and then went back. Okay, I want you to show me that path if you can, okay? So it should take you like 15 minutes. If it takes you much more than that, you're putting too much detail in it, and I want you to skip forward. So I'd go about a week at a time maybe and try to estimate where it goes, and then show me that path, right? So whatever it does, right? If it doesn't go straight, but it does a little zigzaggy thing in between, I want you to see that. Okay, now I actually want to see the date when it starts to turn around. Okay, so when it goes retrograde, I really want you to make sure you indicate that date on your chart. And then also, we're going to, sorry, we're going to mute everybody. Okay, you can unmute yourself if you're talking, okay? I want to see the date that it turns around and goes retrograde, and then also the date that it goes back to going prograde again, okay? So we can kind of see, you know, the path and some of the important dates for Mars in this particular time frame, okay? All right, now speaking of Mars, because that's what we're covering, whoa, everybody, earthquake, no, everybody good. No
Sean, I have a question.
Yes.
It's Erica.
Hi, Erica.
When we tracked Venus, I noticed that it did the same thing. It went up, and then on 5/20 it did the retrograde, and then on 6/3 it went behind the sun. But all planet, is that because of our perspective, our
Absolutely.
reference point, and that's just
Absolutely.
them doing their rotation?
Yeah, so you might remember that this was
Whoa.
kind of like one of the cool things we learned, that the
Mhm.
closer a planet is to the sun, the faster it moves. And so which one's faster, Earth or Mars?
Mars.
Mercury, Venus, Earth, Mars. Earth is.
Earth is faster. So
Yeah.
why do we see Mars going retrograde? Because Earth is passing Mars in its orbit. Now, which one's faster, Venus or Earth?
Venus.
Venus is faster than Earth. So Venus, if we were on Venus, we would see Earth going backwards. But it turns out that if we see Venus going backwards, I'm sorry, if Venus sees us going backwards, we also see Venus going backwards at the exact same time. Venus will do something different. Okay, Mariette, you had your hand up. Why don't you go ahead and ask a question? Turn on your mic. I'm sorry. Just toggle your mic on.
I was just confused about the dates because I worked ahead, but then they're the right dates, right? They're the same as the June 1st through March 1st.
June 1st to 2020 to March 1st, 2021.
Okay, so
Okay.
I'm good.
Okay. Great. Okay. So now speaking of Mars, I want to invite you to get up before dawn, if anybody's interested, because there is a really remarkable thing you can see right now. And actually, I was supposed to show you guys with an early morning star party. I'm not doing it, obviously. But let's go ahead and advance the clock to about 4:30, maybe you could do 5 o'clock. You can do 5 o'clock in the morning. Let's put 5 o'clock, okay? If you just want to go see it, it's actually something you can see. I'm going to go ahead and do that search for Mars again. I'm going to search for Mars, okay, right now. And I want you to, that's the wrong date. Oops, I got to go back. Got to go back to today. Okay, so April, what's the date today?
27.
27th, okay. 27, okay. So I want you to notice something kind of cool. Let's see, I'm gonna turn the ground back on. Actually, what I wanna do is turn the atmosphere back on too. Can you see right now, let me turn off the constellations right here. Actually, I should turn off the boundaries too. Sorry, I'm gonna go back and turn off everything. Just look at the sky, okay? So I'm looking at the sky. And you guys might notice, look at this. Look what 3 planets are up in the sky right now, almost lined up with each other. So Mars, Saturn, and Jupiter, all in a line. And they're actually, if I turn this on, if you guys look, there is the ecliptic. Remember, the ecliptic is the path the sun follows. What do you notice about the planets? They're very
almost
close
done.
to the ecliptic. They're always close to that path, right? Because we're in the same plane with the sun, okay? So this is something that you can see if you get up before dawn. Now, right now, you can already kind of see, I don't know if you can see it. If I go back in time, let me go back a little bit. You notice that it's even darker, right? And then what happens is around 5 o'clock, the sky begins to lighten. And you'll notice, actually, I guess I can pull back a little bit. As you go forward in time, watch how the sky begins to lighten. And you can see that glow over there in the east, right? So the sun is going to be coming up, not for a while, but it's already starting to affect the sky. And then the sun is not up yet, right? The sun is not up. It's almost 6 o'clock. You can still see them, right? But they're starting to fade. They're not as brilliant as they were if you got up early. And then, the sun is going to rise pretty soon. There it is, okay? So the sun is finally up. Actually, what time does it rise? It looks like about 6:15, something like that, 6:15 or so this morning. And then by then, you see they've faded quite a lot. You can't really see them anymore. So the really cool part is to see them a little earlier. And then, if you have a pair of binoculars, if you zoom in, it would be awesome if you had a telescope. Remember the little shining lights nearby, right? We can see the moons of Jupiter. Now, Io, it looks like, is either in front or behind. And I see a shadow right here. Do you guys see that? That is, it's making the shadow on Jupiter, right? That would be so awesome to see. Oh my gosh, is that awesome? Look at Io. Oh, that's so cool. So we can see that sometimes. If you have very clear skies, you can see the shadow as it's passing in front of Jupiter. That was this morning, unfortunately. So
I took pictures this morning.
You saw Jupiter this morning?
I saw
At
Mars.
5:15?
I took pictures of this morning.
Oh my gosh, that's wonderful. Wow.
I know.
What time was it? Was it that early? 5:15?
Yeah, it was actually about 4. Yeah, it was close to
Oh my
4.
gosh. Well, if you were this morning, let's take a look at 4 p.m.
Yeah.
this morning. So you would have seen 4 moons. And then watch what happens. Io or Io goes in front of Jupiter and it appears to
There it
disappear.
is. Oh.
So it would have just like disappeared because it would be drowned out by the light of Jupiter about 5 o'clock. And then, okay, so that's Jupiter. And then right next door, we have our beautiful Saturn, right? The Lord of the Rings. And when you zoom in, you can see, what do you see? The big moon Titan, right? And then of course you can see the rings. And there's a few other moons that can be seen nearby, okay? So remember, it's got all kinds of moons. We won't worry about all that. But there's Saturn. Now, Mars is a very brilliant red color, but it's actually kind of not the most exciting planet to look at because there are not a lot of features to see. Okay, so it actually just kind of looks like, Yeah, so this is like a gibbous Mars, I guess. But it's difficult to see anything at this moment because it's really not very much contrast. So sometimes when they're in the winter, when the caps are visible, then you can actually pick those up. Otherwise, it just looks like a red ball. Unfortunately, it is one of the more boring planets. It's also much smaller than Jupiter and Saturn. So even though it's close, it's actually going to be hard to see any details. But anyways, that's what you can see if you get up early in the morning. You got to get up pretty early, but you can see 3 beautiful stars that are not stars, that are the planets. Okay, now, how about tonight? Let's say you wanted to go outside tonight and see, is there anything to see tonight in the sky? Anybody know of anything that might be happening tonight in the sky? Sunset. Let's go to sunset over here. Look at this, take a look. Actually, tonight is pretty good. Actually, last night would have been even better. Did anybody see it last night? Look at the moon right next to Venus, a little crescent moon. But tonight it'll be cool too, right? Tonight it'll be beautiful. If you go outside in the early evening, this says about, about 8 o'clock, you'll be able to see Venus, super bright, and then the moon, and then there's Betelgeuse down here, so you can actually have a nice triangle shaped conjunction over here. There's Sirius, right? Other things you can see.
What I thought was fascinating is the other night that I took a picture of both the moon and Venus in my backyard.
Oh, you
is that-
did?
Yeah, and I
that's
sent it to you because not only was the moon at
I only
a
thought, wait,
crescent.
the one that you saw me, you sent me had the moon in it?
No, the one I sent you originally was just Venus with the
Just
heart,
Venus.
but I sent you one after that with that has the moon and Venus.
Oh my gosh, I gotta
But
look
the
again.
moon, you can see the whole moon, but you can see just the crescent part of it. But
That's
then
awesome. The part that's lit up. Oh, that's
the
beautiful.
rest of it you can see. It's
Oh, yeah.
so beautiful.
That's neat. So why are we seeing it? Anybody remember the name? How do you see the part of the moon that's not lit up? Called earth shine, right? Some of the light
Earth shining.
reflects off of the moon onto the earth, back onto the moon
Yeah, it
again,
was
and then back
like
to our eye.
that. It was
Okay, so that is, okay, great. So that's something to do. Okay, you guys have, okay, tracking Mars. Okay, so let me just go back to our website again. Okay, so we got a few more people, thank you. And I'm wondering if anybody who wants to tell a story? A mythology story. Do I have some volunteer story? Sorry, I forgot the word story. I have Mariette wants to tell one. Does anybody else want to tell one?
how do you say yes?
You just say yes,
Oh, yes.
or you type yes. Okay. All right. So actually, do you guys want to do that right now? Should we do it? Would you like to do it? Mariette, are you ready to do that? Wait, turn on your mic again.
Should I just read the long one that I wrote for extra credit, or should I just say a little bit about Virgo with a mini?
Well, I actually want to hear a story. It's worth a couple minutes. I mean, what else are we doing tonight? Our
Okay.
class is still short. It's not going to be 3 hours, I promise. It'll probably be about 2 hours or even less. So yeah, so actually, can I put your face on here so that everybody can hear your story?
Okay.
Okay, hold on. I'm going to spotlight you now. Okay, here's Mariette, and your story is about Virgo?
Well, no, I'm just gonna do Perseus.
Okay, tell us. Well, so is the Perseus story that I told you guys or no?
I think it's a little different.
Okay, cool. All right, tell us the Perseus story.
Okay, so Perseus is the son of Danae, who was the daughter of King Arcesius of Argos, Greece, known today as a notable continuous habitation of a human settlement. King Artesius seemed to have it all, but he wanted a son. He sought out the insights of an oracle who told him of Perseus to be born to Danae and would be his predecessor, but also his demise. When Danae was attracting many suitors from her enhancing beauty, King Arcesius locked her in a tower along with her nursemaid, fearing the oracle's prediction. Zeus, a god of many female inspirations, decided that this was his perfect opportunity to be with Danae, as gods cannot appear before humans as their godlike selves. Zeus impregnated Danae through the form of golden rain that seeped through the tower, penetrating her. 9 months after Zeus visited Danae, Perseus was born, and he would not keep quiet. Perseus's cries led King Arceus to discover his existence. In order to spare himself the guilt of putting them to death, King Arceus sent Danae and Perseus out to sea in a wooden casket. Protected by Zeus, the casket made its way to the island Surfios. Here, Danae and Perseus were taken in by Dictys, and Perseus grew up strong and healthy. Danae, because of an obsession with became an obsession of King Polydictys of the island of Surfios, and he plotted to pursue her. Alleviating his obstacle, Perseus, by challenging him to a deadly mission, bring him the head of Gorgon Medusa. Medusa is one of 3 sisters who were once known for their extraordinary beauty, but they defied goddess Athena, and she thus turned them into gorgons. Medusa was the only one of the 3 who was mortal, I think. Is mortal is when you can die, right?
Yes.
Sorry, mortal means you can die. Yes.
Okay, so Medusa was the only one that could die out of these 3 sisters. So that's the one that Perseus was going after. With the help of Athena, Hermes, and Graces, Perseus was able to find and defeat Medusa. On Perseus's way back to Seriphos, he came across Andromeda, who was being sacrificed for her mother's irresponsible remarks about her beauty by the mercy of a monstrous sea serpent sent by Poseidon. Perseus freed her and returned to Surfios, only to find out that he was part of an elaborate scheme constructed by King Polydectes. Seeking justice, Perseus went to King Polydectes' palace and showed him Medusa's head, turning the king and all of the attendant guests to stone. Eventually, Perseus learned of his past and understood the reasons King Arceus are from the very beginning of my story. He realized why that guy sent him to him and Diane. I mean, yeah, come on, these names. Danae out to sea. Perseus wanted to forgive him and took off to Argos. King Arceus hid from him in plain sight, dressed as an elder commoner. Perseus was being celebrated by being presented with games, one of them being the game of discus. Perseus threw a disc, the wind changed, the disc hit the disguised King Arceus in the head, killing him instantly. At the hands of Perseus, even unintentionally as it is, the predicted death of King Arceus teaches those who believe in oracles not to doubt them or attempt to obstruct their predictions.
Thank you very much. Okay, thank you. We would give you applause if we were with you. So thank you. That was wonderful. So that's interesting. So I knew part of that. I didn't know some of those details though. Oh, look, yeah, we could do the hand thing. Everybody do the hand thing. React. Hand. Give her a hand. Thank you. I love it. That's great. Okay. Thank you so much. So who else wants to tell a story? We got some more volunteers.
Oh,
Irene?
I want to take mine off.
Erica?
Mine is like not like hers, like really long. Mine is just like explaining a bit.
You don't have to tell a really long story. It's what it is.
I can say.
So who is this? Sorry, who is that?
Julia.
Okay. Okay. So are you ready? You want to tell it?
Yeah.
Okay.
So mine is about the Amazons. The myth says that they were the most powerful women ever. And in the ancient times, they were said to be a tribal of independent, mildly women who had rebelled against the man-dominated society. They used to live in an isolated place. It was in the city of Themyscira, I don't know, of the river Thermodon. It's in Asia. And They exclude men from their society and make wars against them. Today, they can call them as the first extreme feminists. Little is known about the legendary Amazons, most of which is taken from myths. Only a few historical facts have been discovered to prove the existence and development of an Amazon culture. Some believe that they were just a fable told to confirm the oppressed women of the antiquity. Others said it is a fable that shows the superior of manhood, as in any battle between man and women, man seems to win. Other interesting point is that the legend of the Amazons appears in myths of many tribes. Whatever the case, the truth is that his ancient story has captivated many historians, writers, filmmakers, and has intrigued the mind of all people. It's just that.
Okay, thank you. Hey, once again, if we were with you in person, we'd be able to applaud for you a little bit better. Okay, so thank you so much. How about somebody else? Irene, you want to do one?
No, I don't have one yet.
Okay. So you have until midnight to write a story.
I know I'm going to, but I don't have
Okay.
one to
Okay,
present.
so you don't have to write it. Sorry, you could just tell it in your own words, right? Okay, so is anybody else? That's our two brave people. Okay.
Right?
I misunderstood the assignment as far as the story. I thought you wanted us to write a story of the day we were born now that we have all this information. So sorry.
Oh, well, that's another story. That's your astrology story, which you can get
Got
extra
it.
credit for as well. Did you put it in there?
No, because I needed your help because I couldn't find two of the points because I can't find two of the constellations of where the planets are.
Okay, so why don't actually at the
Yeah.
end of the session, can we do that? And I'll do that with
Yeah.
you. We'll figure them
Nice.
out. Okay. All right. Well, so then I'm going to go ahead and move on, and let's go ahead. You guys have something else you have to do, right? We have a number of things. Wow, we still have more things to do. I forgot to finish that up. So one of the other things that we need to do is you're going to take your final STAR quiz, and it's not meant to be really hard. It's just what it is. But did anybody take it already? I think some people took it already. But I was actually, it's fine. You don't have to take it until next week. You have 1 week to take this, okay? It is 15 questions. And the way it's going to work is going to be similar to what I'm going to do with you right now, which is to practice in Stellarium. And so let's go to Stellarium. And question?
No, sorry.
Okay, so we have, let's go to Stellarium, and I'm going to go ahead and we're going to go to the early evening. I'm going to turn off the sky, the atmosphere, and I'll turn off this line of the ecliptic. And then you will be given these little lines right here. Okay, so you're going to get the little lines, and that should make it a little bit easier. Okay, but you're not going to get the names of the stars. Hold on, let me turn that off. Okay, so on sky, turn off labels if you want to practice for yourself. And I think that's it. Okay, so no labels. You can see Moon and Venus. Okay, so for tonight, actually, this is part of this guide that you need to know. Let's go ahead and start off. Let's try to talk about the stars or objects first. Okay. I'm going to start off hopefully with something you're very familiar with. What is the name of this star or object? If you want to unmute yourself for this time, that would be helpful.
Betelgeuse.
Yeah, that's Betelgeuse. Okay. What is the name of this star or object?
Bellatrix.
So you can actually check your answers, right? You can check it. Bellatrix, very good. So left click to activate, right click to turn it off. Okay. What is the name of this star or object?
Rigel.
Rigel.
Rigel, very good. And what is the name of this star or object?
Say
Saith. Okay, Saith. Okay. What is the name of this star or object over here?
Aldebaran.
Aldebaran. It is the eye of the bull, Aldebaran. It means the follower of this star or object. What is the name of this star or object here?
The Pleiades.
the Pleiades cluster. Now, it's hard to see it, although we can zoom in a little bit, but there is another cluster here. Actually, why is it fading? Okay, this cluster of stars, what is the name of this cluster of stars?
That the beehive? No.
That's the Hyades cluster.
Hyades.
Hyades cluster, okay.
Oh,
Now, yeah, it's just if it
Oh.
points to something in this area, that's the Hyades star cluster.
mhm.
Okay, so you can't see it unless you zoom in. Now, everything else is so bright, I guess it's just fading it for us.
Mhm.
Okay, what is the name, zooming back out, what is the name of this star or object?
Capella.
Capella, right? In the
Capella.
constellation of, anybody remember the
Auriga.
name? Auriga, the
Charioteer.
charioteer. Okay, cool. What is the name of this star or object?
Castor.
Castor. So you want to remember Capella, and I forgot to check it. That's right. So sorry, and then Castor, and then the one next to it is
Pollux.
Pollux. Okay, and this star or object, what is this one?
Procyon.
Procyon, right? It's in.
Procyon.
Okay, and then down here, what is the name of this star or object?
Sirius.
Sirius. Very good. Okay. So okay, so zoom back out. All right. We're going to move this guy just a little bit. And so you can see I've got this pair of twin stars. What is the proper name of the constellation these stars are a member of?
Gemini.
Gemini.
Gemini. The what?
The twins.
The
The common
twins.
name is twins. Very good. Now, if you go from the twins, the twin brothers, Pollux and Castor, you go over here, you have this backwards question mark shape. And at the
Leo.
bottom of the backwards
Oh.
question mark, there is a star. What is the name of this star or object?
Regulus.
It is Regulus. Regulus. Okay, Regulus. So what is, sorry, maybe I should have just gone on to the constellation. This star is a member of a constellation. What is the proper name?
Leo.
Leo.
Leo. Very good. Leo the what?
Lion.
Lion. And lions are regal. So you can remember the name of the star is Regulus, right? Okay, what is the name of the tail star here?
The nebula.
Denebula, Denebula, right? That's the tail star. Actually, the prefix Deneb means tail, right? So we'll see that some constellations later in the summertime. Okay, in between Leo and Gemini is a constellation that's very dim. What is the proper name of the constellation?
Cancer.
Cancer.
Cancer. The common name?
Crab.
The crab. Very good. And if you zoom in, you can see a cute little cluster. What is the name of that cluster?
Beehive.
The beehive cluster, right? That's supposed to be the beehive with some buzzing bees above it. Okay, the beehive cluster. Anybody remember the M number?
44.
M44. M44. Very good. Good.
Mhm.
Okay, so now we're looking at another part of the sky. Let's look, let me turn the sky a bit. So here's Leo. Down here, we have a bright star all by itself. What is the proper name? What is the name of this star?
Is the Alphard?
It is Alphard. Very good. Alphard. Okay. And it is a big, long constellation. Do you remember the proper name of the constellation? With the head is here and Alphard is in the
Hydra?
bed. It is Hydra, the water snake. Right. I just gave it away. Why did I say that? Hydra, the what?
Water
The
snake.
water snake.
Water snake, of course. Okay.
Mhm.
All right, let's see. I'm going to turn this guy a little bit more because I want to see something. If you look right here, we have the shape. You guys probably recognize the shape. I'm going to go all the way to the north. Why don't I? This is the constellation you should be familiar with. What is the proper name of this constellation?
Ursa Major.
Ursa Major. Very good. And the common name is?
Big Bear.
Big
The
Bear.
Big Bear. And the nickname is?
Big
Big
Dipper.
Dipper.
The Big Dipper. And we've learned how to take the Dipper part. This is the star called Doobie. And I actually, if you want to just learn these stars, you can. I mean, I keep learning them and forgetting them though. This one is called Merak. This one is Fad. I know Fad actually. And then this one is Megrez. And this one is Alioth. And this one is Mizar. I know that one. And then this one is Alcade. Okay, but anyways, but if you take the two stars on the end, which ends with the Neb, right? These stars point you right towards this star. What's the name of this star right here?
Sirius.
Polaris, of course, right?
I mean, oh my gosh, yes.
No, North Star, right? I know it's been a while. Okay, don't forget that stuff.
No,
Now,
I knew
this one.
what I was thinking. I said the wrong word.
Oh, okay. Here's the handle, and you can see the handle is bent. It has a curve to it. And so we're going to take the arc of the handle and arc to this star right here. What is the name of this star?
Arcturus.
Arcturus, right? You arc to Arcturus, and then you spike to
Spica.
Spica. Very good. Spike to Spica. Okay, so actually, let's look at the north for a little bit. If you look at this constellation right here, Polaris is at the end of the handle. What is the proper name of the constellation?
Ursa Minor.
Ursa Minor, which means what? Common name.
Little Bear.
The Little Bear. And the nickname for it is?
Little Dipper.
Little Dipper, okay. Over here we have this W shape, and you can remember that one. What is the proper name?
Cassiopeia.
Cassiopeia, very good. And the common name for that, she is the
Queen.
queen. She was the queen of Ethiopia. And the nickname, because of what she's sitting in,
The throne.
the throne. We call it the throne. Some people call it the chair, and definitely the W, but we call it the throne as a nickname, okay? If you go from the center star, you don't need to know this, but it's called Navi, N-A-V-I, and you go towards the Big Dipper, towards Polaris. You draw an imaginary line. You can pass this star right here. It's called ERTH. Okay, I never remember that. But anyways, this star is a member of a constellation. What is the proper name of the constellation? Okay, it's called Cepheus, if you don't remember that, Cepheus. And it is the husband of Cassiopeia. So who is he?
He's the king.
He's the king of Ethiopia. And what is the nickname from the shape right here?
The house.
A little house. Yeah, we say a little house. Okay.
Mm.
And then over here, wrapped around the Little Dipper, right? There's a constellation that we talked about last week, because this star used to be, not that star. Yeah, this star. Where does it say it? No, this star. No, this one. Where is it? Oh, this is the star. Oops. Okay. Oops. Okay. This star used to be the North Star once upon a time. Yeah. Okay. So not that star. This star here, and it's called Thuban. But anyways, what is the proper name of the constellation? It wraps around the Little Dipper, big long one, called Draco the
Dragon.
dragon. Draco the dragon. Okay, Draco the dragon wraps around the Little Dipper. Okay, you can try to look for that if you want, right? So the first stars are in between the Big Dipper and the Little Dipper, and they wrap around, and then the head goes down like that. Okay, so let's see, back over here. We talked about this star being, you arc to the star. What was this star again?
Arcturus.
Arcturus, right? And what is the proper name of the constellation that Arcturus is in?
Bootis.
Boötes.
Boötes, the common
Bootis.
name, the herdsman. What is the nickname for it? Because of this
Ice cream
shape.
cone.
The ice cream cone. Can you see the cone right here? And then the ice cream on the top, okay? We didn't learn this one. That's really cool, but don't worry about it. Okay, and then you spike to the star. What's this star right here?
Spica.
Spica.
Spica, right? And the big constellation that Spica is in is called Virgo, the
Maiden.
Maiden.
Maiden. Very good, the Maiden. Okay, now we have just two more constellations. Okay, so if you go down Hydra, there are two constellations right next door. This one looks, I don't know, like, what does it look like to you?
It looks like a chalice, but it's called a cup,
Yeah,
right?
if you can see a chalice, that's really good, because then you can easily remember the name. What's the proper name of the constellation?
Crater.
Crater, and that is a giant cup, right? The crater, the cup. And then these four stars don't look like much of anything, but what is the proper name of the constellation?
Corvus.
Corvus, the?
Is it the crow?
Corvus is the crow. So crater is the cup, Virgo the maiden, Leo the lion. We don't learn sextants, but there's Hydra, the water snake. We don't learn this. We don't learn this. We don't learn this. We don't learn a bunch. But anyway, we don't learn this one. I wish we did, but it's kind of dim.
Was
Anybody
one
know
of
what
them ever
monoceros
called a
is?
raven?
One more time.
Was that ever called the raven? How come I always call it the raven?
It's Corvus the crow. Corvus is a crow.
Yeah.
Crows
I
and
just-
ravens are really easy to get confused. Maybe that's why.
I don't know why I read that once. It just
You
it
did?
stuck.
No,
It's
I think
it
it's a
just really stuck.
crow. I don't know. We could, you want to look? Let's look. Look it up. I mean, if I'm wrong, that's great. But we've been calling it that for many years. So let's go back.
No, I'm
let's
saying
look.
for me, every time I look at that constellation and I
You
try
keep
to
thinking
memorize
of
it,
raven.
I always think Raven.
Yeah.
But then I love Alice in Wonderland. So
But crows look a lot like ravens. So Corvus, the raven or crow? Okay, we'll look it up. Corvus. Okay, Corvus. Maybe Corvus.
oh, see, it says Ravens.
Oh, it says
Yay.
well, crows. I don't know.
It says commonly known as
The
crows,
genus,
ravens,
blah, blah, blah.
rogues.
There's no consistent distinction. Oh, okay, well, I don't know.
Yep.
Yeah, Corvus, I think we're gonna, well, anyways, yeah, you're right. I don't know. Yeah. How about Corvus mythology?
Hmm. What should be like a dove?
Yeah, the difference between them, it's kind of funny, is this is Raven, yeah.
Yeah.
Corvus constellation, okay, Corvus. Raven in Latin, I don't know what to say. I don't know. Well, maybe I've been doing it wrong all these years. Okay, so it says crow. Yeah, so I just, the story that I know, this is the story of Corvus actually, why he's black. He used to be
Mm.
white and then he became black.
Hmm.
I don't know. I wouldn't worry too much about it. It says, looks here, crow, raven. We just call it the crow. I'm not gonna, you know what? It might be raven, but it might be crow. Let's just go with what we've got. Not a
Okay.
big difference. Okay.
You think it'd be easier knowing with the CC Craven
Actually,
Crow, but
do you
I
know the
always think
difference
Raven.
between crows and ravens? There's not a big difference. And actually, so here's the funny thing. If you guys have seen the black birds around Santa Barbara, are they ravens or crows?
Crows.
They're all crows. Yeah, we don't have any ravens in Santa Barbara City. There are ravens in the neighborhood though. So there's, I mean, not far from us. But it turns out any of the black birds that you've been seeing are crows. So I kind of think of that bird when I think about Corvus myself. Okay, so don't worry, it's not a big deal.
Yeah.
Yeah, let's move on. Okay, so there was a question, somebody was asking, is there a review for the overview quiz? Not really, but if you look at let me just go ahead. It's got little questions on, I just uploaded it, by the way, so I know for a fact that the questions are a mixture of I think I put that in your, it just says it has a little bit of everything. It has something, I'll tell you right now. It has questions on the telescope. It has questions on celestial motion, and it has a couple questions on coordinate systems. So you would have to, review all of that information. You don't have to do they're little questions though. They're not really like detailed questions. So it's more like a little bit of this, a little bit of that, but they're kind of overview questions of the course. So if you think about like what were some of the big concepts we learned with telescopes? What were the big concepts we learned with the sky motion? And what were the big concepts we learned with coordinate systems? Again, you can't make your grade go down. So it will replace a missing grade or it will replace a lower quiz grade. So it cannot make your grade go down. So you have nothing to lose and just take it. And if you do great, that's cool. And if you don't do great, we just won't count. Okay. So otherwise, I don't have a specific review for you. Okay. All right. So now the main lesson for today. So let's go ahead and take a look at our page here so that I can kind of methodically work through it. I want to start off with this right here. I've got a list for you. I'm just going to run through it. The list of Messier objects. So you want to take some notes if you can. You could call this the a Messier lecture if you want. It's really about the sky actually, but the Messier object lecture if you want to call it that. I've never actually called it that. So let's just give it some name and take some notes. Because I'm going to take you here to the Wikipedia page. And you should take some notes. Number one, the Messier objects are a set of 112 astronomical objects cataloged by the French astronomer Charles Messier. You should write that down. And actually, he's an interesting fellow. Again, we're not going to be doing, there's no more quizzes on this. This is just, oh, you do have, sorry, you have a quiz tonight's lecture. That's it. And this is your last quiz, I guess, after you do the other things on Canvas. But there's a little quiz on the topics that we're covering right now. So Charles Messier created this list of astronomical objects, and we're going to talk about those tonight. They're quite beautiful, by the way. They're really kind of neat. This is all of them, okay? All 110 objects, and there are a variety of things. We're going to talk about that in just a second. So who was this guy? So number one, Charles Messier was a French astronomer. There he is, this fellow, noble fellow. The first edition was published in 1771, and then by 1781, it had jumped from 45 to 103 objects. Now, what were these objects? Why are they here? What's going on? And so Charles Messier, you want to know, you could write this down, was a comet hunter. He was looking for comets. And the reason is he wanted to be as famous as the fellow who named the comet Halley's Comet. Who would that be?
Haley.
Edmund Halley. Okay, he wanted to be famous like Edmund Halley and have a comet that would keep coming back, every once in a while, and everybody would remember his name for forever. Unfortunately, he never did have a comet named after him, so he failed. But along the way, he created this list of objects that looked to him with his telescope. He had a small telescope. He was not able to see a lot of detail. And he saw these objects and he thought they were comets. So what does a comet look like? Just for your information, someday you may see one and you'll be like, hey, that's a comet. Or maybe you'll be able to say that looks like a comet and it has a chance of being a comet. If you continue watching it, you'll be able to tell that it's a comet. So what do comets look like? They look like fuzzy stars. Okay, so they are fuzzy little objects. And then because they're comets, they're orbiting the sun, they're going to move. Now, I actually realized that I can do something with you guys that I didn't do with my other class. You guys are going to get a better lecture because I actually want to show you something kind of neat. There is a website that tracks bright comets. So I'm just going to type that in, bright comets. And maybe I'll put one more thing, a finder chart, okay? Because I know they have that as well. So in the sky, let's see, which one do I like? That's not the one I like. Well, Earth sky I always like. Okay, Earth sky is pretty good. In the sky, I feel like maybe that's the one. Is that the one? In the sky. I'll know as soon as I see it. No, that's not the one. Okay. Well, this one kind of works. Below is a list of the brightest few comets that are visible at present. So remember how magnitude works? This is apparent magnitude. And you can see the smallest number is 8.1. Is this visible with the naked eye? Anybody?
No.
No, we can only see up to 6, right? So you'd need a binoculars or telescope. But some of these, actually the 8s are pretty bright. These are quite bright. And then take a look right here. This one is supposed to get up to 3.7. Would you be able to see that with the naked eye? Absolutely. It's in a part of the sky called Lepus. This is right underneath Orion. So that's actually really interesting. Now, unfortunately, that actually means it's going to be hard to see for a while because it'll be behind the sun. So we may be able, I don't know, I'm not sure if we're going to see this one. But anyways, and here's another one that's in Camelopardalis, which is right next to it. We should be able to see that one. And this one is brightening to 2.3. Wow. By May 30th, okay, which is actually coming up. Here's another one that's not very bright. It's actually not going to get any much brighter than it is right now. Okay, so this is a star finding chart, I believe. No, never mind, I'm wrong. Hold on, let's just click this. Oh, this is the one that just broke apart. Okay, this is probably not going to make it after all. Okay, so I'm not sure where the chart is. Where is this? Oh, here it is. Okay. So this is the chart, and you guys want to look for a constellation that you recognize. Does everybody see the W? There's a W. This is Perseus. This is Taurus. Oh no, this is Andromeda. Sorry, Andromeda. This is Capella and Taurus down here. So it's kind of up here, Auriga, Charioteer, Gemini right over here, okay? And this is the end of, well, this is Cancer. Okay, Big Dipper right here. There's our Big Dipper. So it's kind of off in the sky, not too far from Andromeda. Yeah, okay. So it's in the constellation of Camelopardalis apparently. And then I don't know if it'll actually show me. Let me zoom in. Letting me zoom in. I still don't see it though. Oh, I guess you don't actually see it. Never mind. Okay, so it's just showing you where it should be. And that's tonight. Okay, oh, this is actually what I was looking for. You see here, a finder chart. So if you want to track it, this is actually the finder chart. And it'll show you, okay, you can actually put in, oh, that's cool, that's awesome. You can put in the dates and everything. You can zoom out. Sorry, let's zoom out. And you can see how it's moving, right? Okay, so this is where it is today. And then it's gonna go down through Perseus. And then on June, okay, so this shows you the path that it's taking. So it's actually moving past, there's Capella right there. So over the next few days, we're gonna see it moving down. But unfortunately, this comet has broken apart. Okay, so I don't know why I'm doing all this, just because I just think it's kind of fun and we could do it, okay. So let's go back to our Messier object. Okay, so Charles Messier was hunting for a comet, kind of failed, but he came across these objects that looked like fuzzy stars, like comets, except when he went back to see if they had moved, he would find that they didn't move. So are they comets if they don't move? They cannot be comets. So he was kind of annoyed by them. And his chart, his list of objects was these objects that he didn't want to bother wasting his time on. And so he recorded their position so that if he saw them again, he would know to ignore them, okay? Does everybody understand? This was a list of objects that he didn't want to pay attention to because they didn't move, okay? But it ended up that the real issue was that his telescope was not very powerful. And in fact, they are wonderful. They're fantastic objects. So would you please make a list right here of the kinds of objects that you find in his list? There's going to be open clusters, right? Write that down, open clusters, globular clusters, nebula, you don't have to write diffuse nebula, but you just write nebula, planetary nebula, supernova remnant, and we're going to talk about that one in particular, and even galaxies. Now there's other, because I don't want to kind of talk down to Charles Messier, but one of his objects is a pair of stars. And so that's really kind of one of the most boring ones. But the rest of them are really interesting and cool. And I'm going to be showing you pictures of some of them tonight. And we've actually gotten to see some of these ones along the way. So that's actually kind of a fun thing. So anyways, there you go. There's 110 objects. Charles Messier was hunting for comets. In fact, these objects didn't move, and so they weren't comets. And so what are they? They're all kinds of fun things. So you actually have a list of these in the back of your lab manual. Can anybody look in your lab manual? What page do you find the Messier objects in your lab manual? It's in the back, just before the paper, the blank paper.
Yeah, I think they start on, what is it, 50 or 51A maybe?
No, you got to go past 50, but what page?
Oh, sorry, 110A.
Yeah, now, isn't that funny that I skipped to 110? Why did I pick 110?
Because that's how many he found.
Yeah, you see my little joke to you? Okay, so
Yeah.
110 A, B, C, and D are actually the pages of the Messier object. You can look them up. So actually, Messier object number 1, M1, we're going to talk about this quite a bit tonight. It's actually a really interesting thing called the Crab Nebula, and it's the remnant of a supernova, a type 2 supernova, for those of you who remember your supernova types. And some of these we have seen. What have we seen? Let's see. Well, actually, I'm gonna use a better app to go through these, but we've seen some of these. It's too bad, unfortunately, that we can't go out and look at the stars tonight, because I would actually show you M13. It's one of my favorites. It's incredibly beautiful star cluster, globular star cluster. Okay, so let me go back to our page here and show you this really cool app called the Worldwide Telescope. And you can just click on this. Kind of a fun thing. If I had to teach an online class in astronomy lab, I might make you use this just to explore the sky in different places. It's actually really cool. So if you are bored, please, oh my gosh, how could you be bored? There is so much fun stuff to learn. But if you're bored and you want to, this is a really fun place to look around and see different things that are in the sky. And so this is a funny little thing where it actually gives you the outlines of the constellations, right? Just the lines. And you can look down here to the right and it shows you the name. So what constellation are we in right now? And where are the
Pisces.
X's? We're in Pisces, right? And over here you might recognize it.
Pegasus.
Square of
Pegasus.
Pegasus, right? And then you can go over here. There's Aries and Triangulum. You've learned all these. Andromeda, right? Perseus, Capella, Taurus. Okay, you've learned all of these. Orion. Okay, back to here. I don't know what that circle is. I don't know why it's there. I've been looking and I can't figure out what it is. I might have done a search though, and it just remembers. I don't know what it is. I don't know. I'm not sure. I'm not sure. Okay, I don't know what it is. Anyways, okay. But if you look, there's all kinds of things. You can look at the constellations, astrophotography. This is actually a pretty neat thing, right? You've got all kinds of pictures. And but anyways, we're going to look at the Messier catalog. So click the Messier catalog if you want, and you can do this with me. Now, there are 110 objects. And so if you look right here, there are 9 pages of these objects. And so what I want you to do is I want you to click on every single one. I want you to sketch it. And then I want you to, no, I'm just kidding. You don't have to. It was a joke, okay? But if you were curious and you wanted to see, you know, what do they all look like? It could be worth 15 minutes of your time or a half an hour just to try to look through them. And this is actually what we do when we have the Messier Marathon. We try to see as many of these in a single night as we can. And right now my record is 67 of them with a telescope, right? With a telescope. But anyway, so what's really cool about this program is when you click on it, it actually takes you to that part of the sky. And so what constellation is M1 found in? You can look down here. The constellation of
Taurus.
Taurus the bull, right? So it's actually a fuzzy little star. You can't see much, but this is one of the end stars of Taurus. This is the other end star of the horns of Taurus. And anybody remember the name of this star right here, which is the eye of the bull?
Aldebaran.
Aldebaran is down here. So this is the object we're talking about, right? So you zoom in and can you write down M1? And if you didn't already, please write down, it is a nebula, but this is a actual, the Crab Nebula is a supernova remnant. And I'm going to talk more about it, so I don't want to give you too much detail right now because this is actually a really interesting object. And it happens to be Messier object number 1. Okay, so this is a supernova remnant. Okay, let's try number 2. Okay, let's see a different kind of object. So we're going to try to highlight some of the different kinds of objects that Charles Messier saw as just fuzzy little stars, but with a better telescope. And you zoom in, right? When you zoom in, you get much more detail and you can see something like this. So this is an example of a globular cluster. Please write down globular cluster. So what does it look like? What's a globular cluster look like? Can anybody describe that to me? What do you see? You might remember this from class.
Look like spilled paint.
What is it?
To me, it looks like a splash of spilled paint.
Paste?
Paint, like
Oh, like a splash of paint. Now I hear
Yeah.
you. Okay, a splash of paint. Yeah. So if you, this picture doesn't really show you, but all of the individual stars, they're actually making a spherical shape. There's a spherical shape. You want to write that down. Okay, so let me just write down a couple of things real quickly for you. Okay, so we saw M1. You guys want to write some notes down. M1 was a supernova remnant. And now we just found out that M2 is called a globular cluster. Okay, so what's a globular cluster? Well, these are very old stars, right? In the shape in a spherical cluster. A
Is
spherical cluster.
supernova what?
One more time.
Is supernova what?
A
In
supernova
M1?
remnant. REMNANT, remnant. So a globular cluster is old stars in a spherical ball, right? Spherical shape, I don't know, spherical shape. And why are they in a spherical shape? Why are they old stars in a spherical shape? Are they going to fly apart or are they going to stay together?
Stay together.
Oh, yeah, stay together.
Yeah, so there's actually a few thousand stars here, maybe even tens of thousands. And what holds them together? What force is holding them together?
Gravity?
I would think
Gravity. Okay, so the gravity is enough to keep them together. So that's kind of a big deal. So these are actually very interesting. These are orbiting the core of their galaxy. Globular, in fact, sorry, these are orbiting the core of the Milky Way. Let me put that over here. They orbit the core of the Milky Way. And the other day in lecture, I was actually educated and I didn't realize that the number has been determined so carefully. Does anybody know the number of globular clusters in the Milky Way? You need to know this. How many are there? It's a small number. There's billions of stars in the Milky Way, but there are only 157 in the Milky Way. That's kind of amazing, right? So this is how many. There may be a couple more that we just haven't found, but right now, this is the number that we can see. There's 157 of them. So there are 157 different globular clusters that you can look at in the night sky. Not billions, 157. That's it. Okay. And Charles Messier happened to find a whole bunch of them, but not all of them, because he actually was focusing on the night sky in the northern hemisphere. So he missed a bunch of things that are in the southern hemisphere. Okay, so they're held together by gravity. Okay, so this is kind of what I want you to be able to do. There's a handful of different types of things. I want you to have a definition of what these things are. Okay, so back to our pictures again. Let's go to M3. Well, M3 happens to be a same kind of thing. What is it? What is M3? What would you call it? It's another globular cluster. Okay, now you can find this, by the way, if you go into the back of your book and you look it up. Does this agree with our list? Can you guys look at the back of your book real quickly and see, is M1 a supernova remnant? What's M2? M2 is what?
Globular.
Globular. How about M3?
Also.
How about M4?
Yes.
How about M5?
Yes.
Okay, so we got a bunch of globulars. How about M6?
Open.
Ah, something different. Okay, so I want to try to highlight something different to make sure that we see a variety of these different objects. Okay, so this is in what constellation? What constellation? You look down here, and we zoomed in to see it, but it's in Scorpius. Okay, so everybody write down open cluster. M6 is an open cluster. And then a couple of things to know about open clusters, right? So what are open clusters? Are they old or young stars? Which one?
It's young.
That's right, they're young, right? These are born relatively recently. And they're often, if they're blue, right, they're young and hot and they won't live very long. But we know that they're young because they are together now. But what's going to happen with open clusters? Are they going to stay together?
Probably not.
They're not going to stay together, right? They're just a few stars, right? A handful of stars. I don't know how many, but tens of stars, not thousands of stars, handful of stars. And because there's not a lot of gravity, they will drift apart. So I want you to know, you guys know some other open clusters. Do you remember M45? Who remembers M45? Which one is that?
Beehive.
The Pleiades, remember that one? Pleiades cluster. That's another open cluster. How about, anybody remember the Big Dipper? Just kidding. The Big Dipper is another open cluster. I'm not kidding. That's actually, sorry, I mean, we never learned this maybe. But the other one is our sun. Our sun was once a member of an open cluster. Where are the other stars? Where did they go? They've drifted apart, right? To the wind. They've drifted to the wind. So we only see our sun, but in fact, once upon a time, our sun was part of an open cluster. Okay, so our sun was once a part of, our sun was once a part of an open cluster. That's kind of a neat thing to know, okay? All right, so back to our little app. Okay, see what else? Let's see, how about M7? What do you think? Can you
It's the
tell?
same as it's
What does it look like?
open cluster.
Another open cluster. How about M8 though?
This looks more like gases or something.
Yeah, what does it say in our list there? I think finally we have a new thing. What do you guys see?
Yeah.
Nebula with cluster.
Yeah, nebula with cluster. Okay, so I'm going to focus on the nebula part. What does a nebula look like, right? Can you see what a nebula looks like? So
Yeah.
let's write down M8. M8 definitely has a nebula. What is a nebula? It is glowing gases. You see how bright this area is and how dark the surrounding areas are? This is an example of glowing gases, right? And the gases are glowing. Why? Why are the gases glowing? And so this is a particular kind of a nebula called an emission nebula. So emission nebulas are often red in color. And some of you might remember that this is the color of what element? What color element, what element has a reddish color to it when we see it?
Is it hydrogen?
That's correct. It's excited hydrogen. In fact, this hydrogen is ionized. And so does anybody remember the name of the ionized hydrogen that glows with a red color? They're called H, Roman numeral 2. H2 regions, right? H2 clouds, H2 regions, okay? So just for a moment, I just want to make sure you guys can write that down, okay? So a nebula is glowing gases. This is called an emission nebula. The excited hydrogen is what is glowing, and it's H2 regions. What makes it glow? Why is it glowing? And there's another word I can put down if you want to write it down, photoionized. So light is actually making the hydrogen start to glow. And this is a hot, young star is behind it. Okay, I can't see that star, can I? I can only see the glow from the nebula. Okay, but behind it there is a hot young star, and the reason I know that is it is shining with ultraviolet light, UV light, which is energizing the what do you call it? The nebula. Okay, so a hot young star behind that can actually light up the gases, and I can see the gases glow as a result of this ultraviolet energy. So the energy from the ultraviolet photons is causing the hydrogen to get excited and glow. All
So
right.
the stars are the open cluster?
They could be, sure, absolutely. That's a good question. So one of these, there could be one of the stars of the open cluster. Absolutely, definitely. Okay. All right. So so we found nebula. What's still left? Okay, so we got to keep going. This cluster, globular, globular, open, globular. I'm waiting. Oh, here's another nebula, M16. This one has a famous name. Anybody know the name? Can you guys look it up? What did I call it?
The Eagle Nebula?
The Eagle Nebula. Okay, this is called the Eagle Nebula. Okay, and then I'm going to keep going. I'm seeing a lot of clusters. I see some nebulas, but I'm finally going to get to M31 here. Oh, here's another one. Sorry, let me do this one first. M27. Go ahead, write down M27. This is a special kind of nebula, and you can see it has more of a spherical shape to it. Does everybody see a kind of a spherical shape? Okay, so anybody remember what these are called? They sometimes have very interesting shapes. This one also has a little interesting kind of lobes that are a little brighter, and these ones a little dimmer. It has an overall spherical shape. Anybody remember the name of this?
Is that the
It's called-
planetary one?
That is correct. It's called a planetary
It says-
nebula. And this one is from a dying low mass star. A dying low mass star sends off clouds of material, and those clouds of material escape from the star. But as the star runs out of fuel, it finally collapses. And in the center, I can't see, but in the center of this, there's something very hot and dense called, anybody remember? Our sun will do this one day.
White dwarf?
A white dwarf. Okay, so a planetary nebula is a dying low mass star, and it sends off clouds of material. But in the center, what will it have? Has a white dwarf. A white dwarf is the energy that is lighting up the clouds and making them glow. And they're going to actually last for a couple thousand years. I thought it was 500, but I've been educated now. Last for a couple thousand years maybe, but not very long. So it's pretty much just a heartbeat, a couple thousand years. Not very long in astronomical terms, okay? But the reason is the cloud has to be close enough to the white dwarf to be able to be energized, and then it'll fade away. So our sun is going to glow with one of these for a couple thousand years. It'll be quite beautiful. Come back in about 6 billion years to see that, okay? And yeah, all right, there we go. So now move on, and we finally get to M31. Who knows what M31 is? You guys know it.
Spiral. Andromeda.
The Andromeda galaxy, right? So this is another galaxy. So again, Charles Messier did not know that he was looking at another galaxy. He saw the core of the Andromeda. You guys have seen that. I think you might remember that even. It's hard to see the big picture because it's so dim, but we see the core where all the stars are. It kind of looks like a globular cluster in the middle. We can't see it with this picture, but here is a big spiral galaxy, and that was some of Messier objects, right? So this is in fact a spiral galaxy. So we can see, as a matter of fact.
And that's because we see it on its side a little bit, right? That's why we can't
Yeah,
see
we're
it.
not seeing it edge. Yeah, we're kind of seeing it on the edge a little bit, right? So
Yeah.
if we could see it directly, it would be a big circle, right? A big circular galaxy. And some galaxies we see are more circular like that. In fact, let me see if I could jump forward to one that like this one, M51. M51, when you see it, right, we're looking almost like directly above the axis of the galaxy. So when we look down at M51, this is also known as the Whirlpool Galaxy, we see this whole structure. Isn't it beautiful? The spirals coming out of here, right? So every spiral galaxy has between 2 and 4 arms, okay, which is kind of interesting. Now this is in the process of eating another galaxy right now, just so you see that, right? So, okay, so we have, and then M45, don't forget that one. That was our Pleiades cluster, another open cluster. Anyways, this is a little variety.
So
M40,
cool.
M45. So M45 Pleiades cluster. And this is a different kind of nebula. You see the blue glowing gases in this case are called reflection nebula. Okay, now I'm not going to be testing you on all kinds of details. Charles Messier didn't know this. He just knew that he saw something interesting, and then he wrote it down just so he wouldn't keep track of it in the future. Take a look at M40, by the way. Look at M40. Wow, this one is super exciting. It's what do you call it? What is M40? You can look it up in the back.
A double star?
That's it. It's 2 stars. Okay, this is one of the most boring Messier objects, but anyways, there you go. So Charles Messier has 110 of these objects. This is a very famous planetary
Wow, is that the
nebula.
God's Eye?
M57, yeah. Well, M57 is called the Ring Nebula. It does look like a God's Eye. This is taken, by the way, with the Hubble Space Telescope. It's a really famous picture of the Ring Nebula. When we see it, we actually don't see it like that. In fact, this is more like what we see, but even that is not. It's a little bit too colorful. We would see it just as a black and white picture. see it as more like a black and white picture.
Mm.
And then Hubble, when it takes the picture, sees all of the
Mm.
beautiful colors. That's amazing, right?
Mhm.
So I just wanted to give you a little taste. There's 110 of these objects, and they're a mixture of cool things. And as amateur astronomers really like looking at them. This is another one, M104. M104, the Sombrero Galaxy, right? I think it's called the Sombrero. Yeah, M104. And now we're looking almost at the edge, right? And we see this beautiful edge on and this big plane of the galaxy like that. Okay, so there's
wish I could
110
focus
of
it.
these objects, and Charles Messier actually became famous not for a comet, but for his list of objects that amateur astronomers can look at. So if you decide to keep doing astronomy and you get your own telescope, or you go to an astronomy star party, these are the things that you can ask to see. Hey, show me this, you know? And if you're gonna go to a star party, you could get out Stellarium and figure out which objects are in the sky for the evening that you're gonna go to the star party. Because if you come and you go, can you show me? And then people get all excited. They're like, oh yeah, you wanna see it? And they'll take you right to what you wanna see. Anyways, all right. So that is, let's go ahead and take a look at our next link. Our next link is another tool. These are tools that I thought were kind of cool and give you a chance to explore on your own, because we're done with our class. This is kind of just for you. I'm not gonna do, there's no more stuff to do, but here's another one, Google Sky. It's pretty neat. I mean, it's actually really cool. This is Google Sky, and actually, you're like, what am I looking at? Well, it's kind of like Google Earth, very much like Google Earth or Google Moon. You guys know you can go to Google Moon, Google Earth, Google Mars, right? There's all these different. It starts to repeat if you zoom out too far. So let me zoom back in. There's a band of light across here. Does anybody want to guess what that is?
Milky Way, maybe.
Of course, that's the Milky Way,
Mm.
right? And actually, it's actually harder than you think to find stuff. Although I think if I know how to do this, okay, it's like you zooming around, it's kind of hard to find anything you recognize, right? But
It
if you
looks
look
really
around a little
squarey.
bit, huh?
Oh, I'm just saying, for me, it looks like a bunch of little squares.
That's it. Well, there are a bunch of little squares. Oh, you don't see any stars?
No, I mean, I do, but as they move, it just looks like this is just a bunch of
Yeah, it
little
takes a
pictures
second
put
probably to
together.
come back. Hold on,
Yeah.
I will stop in a place where we can recognize something. At some point, I will recognize something. I know I can recognize something. I'm just trying to find something that I can recognize. I'm trying to find something, anything. Oh, there's something, I recognize that. Anybody recognize that? 3 stars in a line like that.
Oh yeah, Orion.
Orion, of course, right? Orion. So this is kind of cool. Okay, so but you can see how different the colors are. Look at that's
It's
Betelgeuse,
Betelgeuse.
Bellatrix, Rigel, and Saiph, right? Those are the 4 stars. There's some interesting little stuff going on right over there. Wow, that's pretty freaky. Look at that. And
Is
then
that
of
the
course in
beehive?
Orion down here, this is M42, the Orion Nebula, which we did look at.
Is that the beehive? Or no?
Oh, that's the beehive. That's that what it is? No, the beehive's
No.
not there. We got to go up to Gemini. Hold on, let's find Gemini. Here's Gemini, the twins right here. And then let's find Leo.
Oh, now I'm thrown off.
Yeah, here's Leo's over here. It's a little confusing. Yeah, you can't put on, oh, can you? Oh, look at that, it's a lot easier. Okay, that's a lot easier. How do I turn it off again though? I don't want to turn it on the whole time. Okay, can I go back home? Oh, good.
No,
Okay.
there it is.
You could just do that. Okay, cool. Okay, so now you can kind of, if you zoom in, you can see. So the beehive should be right here. There it is. There's the beehive cluster. And you can see this is the beehive. And then these are the buzzing little bees around it. Okay, that's kind of fun. Cool. Actually, I didn't realize how easy it was to turn on the constellations. So I was trying to find things just by finding them, and it's a little bit hard. But if I turn on the constellations, it becomes much easier. So here we have the constellation of Taurus the Bull. Okay. Actually, let me do this, the Orion Nebula. Okay, let's talk about that. Let's turn that off for a second. There's some interesting buttons right here, and I want to show you something interesting here. I can click on the infrared, And this actually shows you the sky, not in the visible part of the wavelength, but in the infrared. And so do you see this line of brightness, sorry, that goes up and down if I zoom in? Anybody know what this bright line might be? What do you think that might be? And remember, you can't really see the whole bright line normally. You just see part of it. What would it be? What do you think that bright line might be?
Is that
That's
still
actually,
Milky Way?
that is the Milky Way. Okay, so this bright line is actually the Milky Way. And it's going up and down because this picture is repeating itself, actually. But you can turn it off again, just slide it over, right? But you can see some interesting things. There's more infrared light coming from the Milky Way than from above and below the Milky Way. What is causing the infrared light, right? What are we seeing? And what's really fun is that the infrared picture gives us a different picture of the sky than we normally see. In fact, one of the things I want you to know is that with infrared, you can see behind the dust clouds that normally block your view, right? So the dust clouds will normally stop you from seeing details. But if you use infrared, then you can actually see behind the clouds. Let me turn on the constellation again. Okay, where is Orion again? Where is Orion? Oh, here we go. I want to show you. I think this will work. Okay, so maybe not. But if you turn on the infrared, yeah, you can't tell. If you remember, I said that behind the dust of a nebula, there are actually bright stars, right? So one of the things that the infrared picture does that I can't see so much right now, but it shows you the stars behind the clouds when you use the infrared. Maybe I can find some other area. Anyways, I just tell you, I'm going to just tell you that infrared lets you look behind the dust to see the stars that are behind the dust. Okay. Now here's another picture that I want you to see. It's called microwave. And so this is another way to look at the sky. So I'm going to zoom way out, and I want you to see, first of all, do you notice that there is microwave radiation? So remember, microwaves, are they longer or shorter than visible light?
Longer.
They're much longer, that's right. Same microwaves that you use to cook your food are actually everywhere in the universe. And if you can, please write down the microwave radiation that we see is leftover from the Big Bang. The universe has cooled off dramatically, and we call this the microwave. I'm going to write it down for you. We call it the microwave background radiation, and it's everywhere we look. And so radiation, microwave background radiation. So this is not dangerous radiation. It just happens to be everywhere we look. And it's a remnant of the original hot temperature of the Big Bang. But now it's cooled off to a very, very tiny 3 Kelvin, about 2.7 Kelvin, about 3 Kelvin. Now in 1990 or earlier, we believed that there was no variation in the background temperature, that every color would be the same everywhere we look. And this data that you're looking at is relatively recent, from the late 90s and early 2000s. And we finally can see little differences in the radiation. And that's good, because we couldn't explain why the universe had galaxies, okay, before. But with this picture, because there's little tiny variations, it turns out this makes more sense, because we see little variations in the matter distribution. So before, when we saw just one color uniformly everywhere, it was very confusing. Why is there any clumpiness? Why are there galaxies? But this picture is much more comforting. It helps us understand that the universe is not exactly the same everywhere, that there are little tiny variations. Okay, so please write down the words if you can. This is microwave background radiation. Was there a question? I'm sorry, I didn't hear that.
Yeah, it was that.
This was the question? Okay, yeah, microwave background radiation. And so it's about 3 Kelvin. That's the temperature of space, about 3 Kelvin. I mean, the real number is 2.7, but don't worry about it. It's about 3 Kelvin. And it's not exactly the same, right? There's little tiny variations, which actually are things that show us that the matter is not uniformly spread out, but it has little clumps, and those little clumps eventually will become galaxies, okay? All right, so that, getting pretty close here. There's one more really neat thing in this app, in this page. Take a look. So we turned off the microwave. Look at this. If you click on historical, this shows you the ancient star charts. This is actually really cool. These are the original Greek pictures. You can go back and like, what did the Greeks do? This is actually what they used to look like. These are the star charts, and you can see the animals that made up the star charts that tell the stories of mythology. And they're kind of cool. You know, you can just kind of see the constellations originally. You turn on constellation and then look at the historical picture overlaying it. You can see how they've changed over time. And I think you'll enjoy it if you want to explore a little bit. So like, what did we learn recently? That's our bear. Look at our bear. Look at that bear. That doesn't look like a bear, but it is a bear, I guess. This is just a weird looking bear. How about, you know, and you could do, anyways, I'm not going to do it. Oh, there's the lion. Oh yeah, this is really cool. But the lion used to have a much longer tail. And now this puff of the tail is considered a different constellation. It's called Coma Berenice, but it used to be the tail of the lion. Okay, so there's another constellation over here called the hare over this one. This used to be they've changed it a little bit. Hold on a second. Coma Berenice, but actually it used to be the tail, the end of the tail. Turns out. Okay, well, they haven't shown us that far back. Anyways, it's kind of a fun tool. Okay, back to our story. Let's go back to our list here. Okay, so Google Sky, just like a fun tool, but I want to actually focus on one particular item, the M1, the Crab Nebula, and tell you a little bit deeper story. And that'll be kind of the last thing that we're going to talk about. Oh, I have one more tool. Oh, I forgot. I actually was going to show, let me wait actually. Let me tell you about the Crab Nebula. So we're going to go to a NASA site. Can you guys see NASA Hyperwall? Everybody see it? NASA Hyperwall. Okay, so the Crab Nebula is a supernova remnant. Everybody remember that? The Crab Nebula is a supernova remnant. And this article was written in 2018, still pretty current, pretty cool. And actually, before we look at this little animation, I want to actually read this little paragraph with you, okay? So let's read this. This is kind of, you guys might remember this from class. If you took my class, I definitely bring it up at some point. Maybe if you took it with another teacher, you probably remember it as well. But the Crab Nebula, Messier 1, is the remnant of a supernova that exploded in the year 1054. That's pretty remarkable that we know that. It's M1, right? This is the first supernova that we identified. And we discovered that it started in the year 1054. And the reason was that in this cloud that we were watching, actually, let me just talk about that. I feel like I should just talk about it. Let's do that. Let's talk about it. Go back to Google Sky for a second. Let's look at that again. Let's go back to, I can actually probably search, right? Can I search? M1. How do you search? Anybody? Search, you see a search bar? I don't see a search. Okay, then I have to find it. Okay, I gotta find it. Where is it? Anybody remember the constellation Crab Nebula is found in? Taurus the Bull, okay? Now here's Taurus. Turn off the historical. And right here, okay, there it is, okay. So there is the Crab Nebula. You guys see it? It's the little fuzzy object. You guys see it? And so they started watching, it turns out the first people in the early 1700s, late 1700s, big telescopes saw the detail and they called it the Crab Nebula. That was the first time. And what they saw year after year, something kind of interesting. As people kept track of it, they noticed that the next time they looked at it, 10 years later, it was a little bit bigger. And then 10 years later, a little bit bigger. right? And I'm zooming in, but I want to give you the idea, right? It got a little bit bigger. What happens when you see something getting bigger is you can ask the question, if that thing is getting bigger, how fast is it getting bigger? And then the next question is, when did it start, right? Play the movie backwards and ask, when was it just a tiny little dot in the sky? And they did that calculation and they found it was somewhere in the year 1000, between 1000 and 1100. And when they went through the astronomical record, they discovered that in China, that they recognized in the year 1054, this special star in exactly this location of Taurus, the bull, right here between the horns of Taurus, the bull, right next to this star, was a guest star. And so you want to write down a couple of little details. The star that they saw, this guest star, was visible for about 3 weeks during the daytime, and then for about 2 years at night, okay? So actually, let me just go ahead and write that down for you. I want you to write that down. So M1, visible during the day for about 21 days, right? It was so bright you could see it during the daytime. And then for about 2 years at night before it faded away. So visible during the day, like when the sun was out for 21 days, it was so bright that you could see it. So we've never seen that. You and I have never seen that, because if we had, I would be able to say, just like when we saw blah, 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 it would be amazing. Everybody on earth is gonna remark. If we see something like this happen in our life, you're gonna know about it. It's gonna be really amazing and something kind of special. Okay, maybe it'll happen. They're supposed to happen every few hundred years, right? So we should get one. But anyway, back to the story. Okay, so the Crab Nebula exploded in the year 1054. This guest star was observed around the world, most notably recorded by Chinese astronomers. The supernova was triggered when the original star, which was a red supergiant, abruptly collapsed onto its iron core. That is called a Type II supernova, and rebounded to expel most of its layers of gas into a blast wave. This is the blast wave right here, expanding away. This wave is seen as an optical and infrared set of filaments that continues to impact surrounding material. This material was expelled from the dying red giant progenitor 20,000 years before the supernova. The ultra-dense remnant core, called a neutron star, is crushed to the size of a city. Spinning furiously, the neutron star sends out twin beams of radiation like a lighthouse. A lot of this energy comes from the neutron star's intense magnetic field. Now, does anybody remember the name of a rapidly rotating neutron star? Anybody remember that one? Okay, anybody? A rapidly rotating neutron star is called a pulsar.
Oh, yeah.
A pulsar is left at the core, right? There's a pulsar at the core. This is a rapidly rotating neutron star. Remember, neutron stars are incredibly dense, right? A neutron star is the size of a city, okay, made of neutrons. Just a big ball of neutrons. It's neutron degenerate matter. Okay, you don't need to know all that. It's like 20 kilometers across.
Will you be sharing your notes?
We what?
Will you be sharing your notes?
Yes, I will share my notes. Yes.
Awesome.
Yeah. Okay, so, all right. Back to our story. Okay, so now let's watch this animation because it's kind of cool. So astronomers want to look at the sky in a variety of different ways because every color kind of tells you something different, right? So I need to start this and then I can maximize it, okay? So this is the picture. If you take a look at the first picture, it says radio waves, right? And then this is the telescope that produced the image, the Very Large Array. And you guys might remember me talking about that before.
Is that the
It's
one
a-
in New Mexico?
That's right, the Radio Telescope Array. And the telescopes are linked together to act like a single telescope to give you better resolution. Let's just look at the pictures. The first one is radio telescope. And that's the reddish picture that you see. And again, can we see radio waves? Of course not, right? So this is it a real color image or a false color image right now?
False.
That's a false color image because we can't see radio waves. Okay, our next picture is kind of a greenish color. It's infrared. Can we see infrared?
No.
So once again, this is a false color image, right? But this is from the Spitzer Space Telescope, which by the way, has just retired, unfortunately, and is done now. Spitzer is done.
Whoa.
And then here's optical telescope. Hubble is showing us the very thin filaments, right? All these interesting structure. And then here we have ultraviolet from XMM Newton telescope. And you can still see it's a big cloud, right? And then I think we have now X-ray. Now I want you to notice that something really bizarre just happened when we look at the X-ray picture. This is the Chandra Space Telescope. What do you notice about the cloud? Does it look the same? Or do you see something different? Does anybody see anything interesting right now?
Yeah, it's like something, there's like circles around.
That's right. You see the disc right here? There's a disc. And do you see a jet and another jet?
Yeah.
Yeah, it's like a
Okay, so
bullseye.
this is actually, you're looking all the way to the core of this. This is actually really cool. So this thing right here is the pulsar, rapidly rotating neutron star. And then what is this disk around it? Does anybody remember the name of something that when you have a neutron star, a white dwarf, or a black hole, when you get a disk of material around it, what is that called? Anybody remember the name?
Oh my gosh. A pet.
I'm writing it down.
Yeah, yeah.
The accretion disk, right? This is a region that's near the pulsar. That's very hot, very hot. Sorry, let me write the word very hot, which means that it actually radiates visible light as well as all the way up to the X-ray. And it turns out this is kind of interesting because I'm showing you that picture of the X-ray. The X-ray shows the accretion disk as well as the jets. Now, there's something important about jets. There's always two of them. One is a north jet and the other is a south jet. Does anybody remember what causes the jets to occur? What does the jets tell us? What causes the jets? North Pole, South Pole, who remembers?
The gravity.
Not gravity, no, not gravity, definitely not.
And I'm sure it's all gonna come to us as soon as you say it.
Because there's an accretion disk, you get this north and south. What is that north and south? Who remembers north and south? The Earth has a north and south, doesn't it?
Poles.
Yeah.
That's right, north and south pole. But what kind of pole are we talking about?
Magnetic.
Thank you, thank you. Intense, intense, powerful. I'm going to use really big words here. Intense magnetic field, right? That's what's creating the jets that come out of this object. And so we see it in the Crab Nebula, and we see it when we see this picture. It appears when it wasn't visible before. Before we saw the cloud, but now we can see the jets. Okay, and I think this is kind of cool. So what you want to understand is astronomers are probing and looking at the universe with not just colors of light that we can see, but lots of other colors of light. And together, this is the composite image. You see it's even more beautiful than before, right? You can kind of see that little faint purplish outline. Again, false color image of the X-ray picture showing the jets, right?
You
And
know,
then
I
if you
have to
scroll-
say, Sean, the stuff that you're showing us right now, I mean, it's just fantastic. And I'm sure we all could have Googled it or whatever ourselves, but what a helpful, like you're saying, the tools to read it, all of that, write notes on it, but to see it and have visuals is just phenomenal.
Isn't it beautiful? Yeah, so
Oh.
this one, you can never get tired of looking at these pictures. They're really quite beautiful. So if you go down, this is actually just double time if you want to go faster. But here is the composite, and then they have the individual pictures. So I see cloud, I see cloud, I see cloud, I see jets, right? I see a disk and I see jets. And so it was only when we first started taking these X-ray pictures that we could see all the way inside and understand more of what was going on in this Crab Nebula.
Is it possible to do a gamma ray on this or no?
Yes, well, so now that's actually very interesting. So gamma ray astronomy is very new. Okay, there's not a lot of telescope. So there's one telescope right now called Swift, and it is actually detecting gamma ray bursts. So gamma rays don't usually come sustained. They come in just little bursts of energy, and they come from very violent things happening. In fact, I think in your lecture, you're about to learn about them. Gamma ray bursts come from galaxies, the cores of galaxies. And so that's actually one of the ways that we look for them. So they happen in very dramatic events, like the merger of two neutron stars, or maybe also white dwarf mergers, but they happen also when in the cores of galaxies in very dramatic events. So
But is
anyway,
the core of galaxies black hole?
yes, that's right. That's exactly right. Okay, so actually, that's something else I wanted to tell you guys about. You guys know that, right? I should have made that a point. Let's see if I can bring that up. Oh, here's what I have. I have another tool. Finally, I forgot my last tool. I wanted to show you this tool. This is, I don't want you to download this because it's a program for professionals. So I don't even understand it all, but I've been trying to play with it just to show you guys a little bit. This program, can you guys see, it's called Aladdin. And this actually is looking at, I don't know if you can see, you know what I'm looking at. Maybe you guys can see, this is actually the 3 stars in the belt of Orion right here, okay? And what I want to do is go over just a bit to, there's the Pleiades cluster, right? Do you recognize this star right here? That would be Aldebaran, right? See how much harder it is to see anything? This is pretty crazy. What I want to do is I want to talk to you about the Taurus, the bull, right? This is a visible light picture. This is a radio picture. Now, you'll notice something very bright over here. Do you see this thing right here? What is that bright spot? And that is the Crab Nebula, it turns out. So the Crab Nebula in the visible is basically invisible. You can't see it. It's not very bright at all. I mean, really, there it is. I mean, it's there, but it's really not that special. But something very interesting, the powerful magnetic fields of the Crab Nebula are actually generating radio waves. Now, I don't think we're going to end up talking about this in the lecture, but just to tell you, it turns out that the magnetic field of the cloud used to be even stronger and actually would have trapped electrons inside of the magnetic field, made them spiral around and emit light. And gradually over time, as the magnetic field got weaker, the electrons that are captured have to go slower and slower and slower until finally the waves that we see are just radio waves. But it's the 5th brightest radio source in the sky. Now, this actually has way too much information. I'm actually blown away by all of this. But here is an X-ray picture, and let's see if it works. Did it load? Oh, there we go. Okay, it's loading. Hold on 1 second. I actually didn't check this before. Okay. Okay. So the X-ray picture is not quite working the way I expected. Darn it, it's not really working. One of the things that we discovered is that the center of every galaxy, we will often find an X-ray source. Actually, you know what? This program is way too complicated. So what I wanted to tell you, let me just tell you in words. Actually, I could write it down for you. This is kind of important. In the center of every galaxy, does anybody know what we have the center of every galaxy?
A black hole.
That's right, but not just any black hole. Who knows what kind of black hole?
A super black hole.
A super massive black hole, right? We have at the center of every galaxy, we have a super massive black hole. And normally black holes are invisible, right? Black holes are black, right? Because they trap light. So they are invisible normally, right? They're black, they don't shine.
But what about why are
Except-
they orange?
Yeah, but why do we
Oh.
sometimes see them, right? And
Mm,
the time that we see them is when they have an accretion disk, when they're feeding, when they're eating something, right? Feeding, they
Pancakes.
have an accretion disk. I know, right? And when they're feeding, we can see them with this hot accretion disk. We see X-rays coming from them. And so it turns out once we started to take pictures of the universe in the X-ray, we realized that there's black holes all over the place, including at the center of every galaxy. So my last little thing I do want to show you, and I realize I kind of forgot to show you guys, but if you're interested and you want to, in the summertime, let's move forward to the summertime. I'm gonna move you forward to a couple months into the future. Just give me 1 second here, into June, let's say. And you're gonna have to wait a little bit. Let's see, June, where is it? June, maybe July. Let's go to July. A little bit later. Where are you? Oh, I'm looking in the wrong place, that's why. Here we go. Okay, so I'm looking in June. June is fine, okay? Late June.
We're looking at your notes.
Yes, I'm sorry. I'm just getting it
Oh,
already. Okay, here we go.
sorry.
Now we go. I'm looking at June. Here we go, June. And as you can see this band of light. Here's our Milky Way. Milky Way. So we have this constellation. Let me turn off this stuff. This is there's a little shape right here. This is the handle. Here's the spout. You can see a little teapot shape, right?
Sagittarius.
And this is called Sagittarius, and it is the Archer, right? We've talked about this. Oh, I already showed you guys this, didn't I?
Yeah.
Oh, I did. Okay. So did I show you what happens when you go over and up just a little bit? What do you find? What's right there? I mean, it's not there, but it's close. Anybody remember? Okay, it's called, write it down, Sagittarius A star. Write that down, okay? This is the abbreviation, SGR, but write down Sagittarius A star. What is Sagittarius A star? Who knows? It is our black hole, right? So it is our black hole. It is the center of the Milky Way. There's nothing to see there because there's no imagery. But in fact, people have been watching this area for very many years, like 30 years almost. And actually, maybe we'll finish off with one final thing. You guys want to see something? Something kind of cool. So Sagittarius A star is a supermassive black hole at the center of our galaxy. So our Milky Way, supermassive black hole is called Sagittarius A star, okay? And it has a mass of about 4 million suns, right? About 4 million suns. It's kind of cool. And so it is a supermassive black hole, right? 4 million times the mass of our sun. And then the last thing, then we'll finish up with a quick little video clip showing you the stars that are nearby. Okay, so let me show you that. stars orbiting Sagittarius A star. Okay. Can you see my screen? Not yet. Okay, hold on. I keep jumping. Okay, I'm just doing a little quick thing. So I said stars orbiting Sagittarius A star. So if you look, this is a video clip, and this is mainly done in the infrared. But in fact, you can see that there's stars that are orbiting. This has taken over 20 years to be able to show you this movie. But that little picture of stars, you can see they're orbiting, and they're orbiting a blank spot. There's nothing there, right? Oh, actually, maybe there's, should we do the simulation? First, let's watch an ad. Hold on.
Build
Jump.
custom industrial.
Okay, oh, this is like 2 minutes. Let me zoom in. Okay, here it is. I'm going to show you in the lecture tomorrow, so. But they're orbiting an invisible companion. And the only thing it could be is a supermassive black hole. So even though we can't see it, and our black hole is normally not feeding, it turns out, we can see the orbit of the stars nearby. You can see the orbit of the stars nearby, and that from that we can figure out what the mass of this object must be. So this invisible object, which is super tiny and compact, can only be a supermassive black hole. Okay, so I think I am done. That is all the stuff that I wanted to talk to you about. I think, Erica, you wanted to ask some questions. We can come back to that. Does anybody have any questions for me? You want to talk about anything? So let me just finish off then. Anybody have questions? Mariette, you just took your mic off.
No, I just want to make sure I could say goodbye when.
Oh, thank you. And actually, I just want to say thank you for all of you for your patience. And in the midst of all of this difficult situation, I hope that you are taking a few minutes for yourself to, just to relax sometimes. Actually, I read some really good advice. In between all your Zoom sessions, make sure you schedule time for yourself to do something else, something just for yourself to relax. And don't be busy all the time. You need some downtime. And maybe one way is to go outside and just look at the stars for a few minutes, just look up and see these marvelous stars. And then remember that you know them a lot better than you did before. And I don't know if you remember your first night with me, but I promise you were going to learn how many constellations, like 20 constellations. I think you know at least that many now. And it just gets easier the more you do it. So just keep it up. Keep looking at the stars. You can find new constellations. Get an app, and you can learn new constellations anytime you want. And then remember to be good to each other and be patient with each other, because this is a hard time for everybody. So just, do your best. And once we get out of this, we can be social again. We can have star parties, and we can, be with each other, give each other hugs, and not be so socially distant. But until then, be strong and carry on, okay? So thank you guys so much.
Do you have any summer classes, Sean?
We do. So there's going to be summer online class only, just online classes. I'm going to be teaching my first online class ever, just first summer session.
But
I'm going to try it out.
Advanced, is that?
What was that?
Is that an advanced class?
No, just the same. Earth 101.
Oh.
Yeah, we have the black holes class in the fall. It was really fun. Kind of crazy, kind of mind-bending. It's actually a really fun class. But again, don't take it unless you have room for something like that.
Yeah.
Yeah, it's very fun. Very philosophical too. We talk about quantum physics and things like that. So thank you guys so much. I'm not going to hold you anymore. If you have any questions for me, now would be the time. I know Erica has some questions, but otherwise, thank you guys so much and have a wonderful semester. Good luck with your finals. And you can send me email if you have any questions, okay, about your grade or whatever. Okay, thank you.
Thank you. Bye.
Thanks,
Bye.
Sean.
Bye.
Bye. Take care. Okay, Erica, what can I do for you? Oh, she's gone.
It just,
Oh, no, you're still here.
no, I'm right there. Well, actually, the other tool that you showed us this evening is really going to help me with what my question was.
Okay. Oh, you
Because-
mean because I showed you on Stellarium?
Yes, you showed me on Stellarium and I couldn't find my constellation because mine doesn't give me and no matter how close or far I got, it stayed in the middle of 3 constellations. So I'm like, what do you call that?
Okay. Okay. So if I put the boundaries on, does that help then?
Yes, because even though I downloaded it on mine, it won't let me. So I have to only use the web one. But
Oh, you can't
today,
run that program. Okay. Well, you want me
right,
to do it
but
with you? Let's do it together then. Hold on.
Oh.
Okay. So hold on. Let me see. Do you mind telling me your birthday?
No, it's April 3rd.
Okay. Hold on. April 3rd, 3.
Uh-huh.
Okay. Oh, you just had a birthday.
Yeah.
Okay. April 3rd. Okay. You want to tell me your year?
Oh yeah, 66.
66?
Mm-hmm.
Oh, you're the same age as me.
Yeah, a little
My
bit.
birthday's
You're like 2
67.
years young. Yeah.
Yeah. we're almost
December
the same age.
7th.
Yeah. You know that one, huh?
I
Pearl Harbor Day?
there's- No, there's certain things that when people tell me it just sticks. And it's
Okay. What
just
time were you born?
3 a.m.
3 a.m. Oh, I was born at 3 a.m. too. Oh, that's what my mom said. Maybe 3 a.m. is the popular time, huh?
Right. I looked at my birth certificate.
Oh, really? Oh, that's
Mhm.
cool. Okay, hold on. I'm going to bring up the Stellarium. Okay. So, okay. So I went ahead and dialed up your birthday. Okay. So you want to tell me, so first of all, we could do this, turn on the
No.
constellations.
Mine is 66.
Oh, 66. I'm sorry. Yeah. Okay.
It's okay.
And then we do the options and we go to star lore and
Mhm.
show boundaries. Okay. So let's go ahead and start looking. What planet did you want to find?
The 2 that it was Mercury and Saturn are
Okay.
really close together.
Okay, let's go ahead and find it then. So Mercury,
Okay. Mm-hmm.
oh, I put 4, let's put 3. Okay, Mercury. Okay, I'm going to turn off the ground. And now I can see. Okay, so Mercury is definitely in what? Oh, they're really close together. Where's Mercury? Definitely in what?
And Pisces. That's
In
what I put.
Pisces, for sure in
Pisces.
Pisces, along with the Mars and along with the Sun.
Yeah, I
So in
know.
astrology, that's considered incredibly powerful. That's a conjunction, right? All right, so that's pretty powerful. And then Saturn is actually right next to it in Aquarius.
Aquarius. So I have 2 Aquarius, 3 Pisces, and the rest are Leos.
That's interesting. Oh, very
Mhm.
interesting. Okay, so that's good.
Yeah, I just
Now you can
I
write
was
your horoscope.
no kidding. That's what I was doing right before.
Oh, yeah, that
When
was
you
your
s-
story.
when you were telling me, yeah, tell me your story. I was making up my story of
Oh, okay. Well, you can tell me that story. So you can write it up and put it in Canvas. You still get extra credit for that.
Okay.
Okay, good.
Okay,
All right,
so
good. So everything else good? You getting through
everything's-
this? I know it's all
I'm
stressful, but
doing- I am.
wow, you sure did well on that last test.
Man, I don't know if you notice the times that I submit stuff. I mean, my time between 11 p.m. and 4 a.m. Those are my time to do my work.
Ah, okay. So that's what
Yeah.
happens. Okay, well,
Yeah.
anyways, I was really happy that you had a test to score to reflect your achievement level. So that was great. It's
You've
good.
been amazing. I look
Aw,
forward
you're
to
a very
the
good student, and it's such a pleasure to have you as a student.
I look forward to